Take me out to California. Take me out to California.
Hey everyone, it's David Bombal once again talking to Chuck Black. I'm based in Oxford in the United Kingdom. Chuck's based in California. So again, please forgive us if we have technical problems on the call. Hopefully we won't have today. Chuck, how's life in California? Let's start with my standard question.
Yeah, it's the basic nerd question. How's the weather? Is
Yeah.
it too hot for you? Yeah. No, it's nice
England.
and sunny.
We always talk about the weather. Sorry, go on.
Yep. We can talk about the World Cup. France
Tell us about the World Cup. What's happening?
France versus Croatia. Your guys, England, just got booted as of a couple of days ago,
Thanks for reminding
unfortunately,
me.
but should be a good game.
And who are you supporting?
This is very easy for me to say. My wife is supporting France, so I think you have your answer right there.
Croatia then, is that right? Because you want to sleep outside.
Now, come on now. Domestic tranquility, that is the rule of life. So
Well, good luck to France then.
that's right.
Sorry, Croatia.
Yep.
You'll have to send Chuck hate mail. So, Chuck, we've been discussing quite a few SDN type related topics. And one of the topics that always seems to come up, not that it's perhaps an SDN per se topic, is whitebox switching / bare metal switching. Can you tell us a bit about that and, what's your opinion about it and, give us a bit of an overview of what that actually is?
Yeah, so the high level overview is that this is kind of what people like Google, Facebook, Microsoft, Amazon, etc., the really, really big guys have been doing for a while. They kind of, my opinion anyway, got a little bit dissatisfied with the networking vendor industry and their responsiveness in terms of, coming up with features, creating affordable or, reasonably priced products that did what they wanted them to do, and the turnaround time was too long. And consequently, they began to look and say, I could get this off-the-shelf silicon and put some hardware around it and put Linux or whatever type of networking operating system I might be interested in on top of that device. And I would have a networking switch that can do things just as well and for a lot cheaper than I can if I bought it from the big guy vendors. And so they began to do that. Not only that, but they also began to open source their actual network operating systems that ran on these switch hardware devices that they had created. So you see that within the Open Compute project, you have this thing called Open Networking Linux. From Microsoft and from LinkedIn, they open sourced the switching software that they created for their own data centers. And basically, the idea is that you can take a piece of hardware, a hardware switch that you buy from somebody that has no software running on it. You buy this bare metal type of device for a very inexpensive price, and then you just load the operating system onto it, and you get economies of scale because you're buying the same exact thing over and over and over again. You're in control of the software. The software is being contributed to by many different parties, including people such as Facebook or Microsoft or Google or whoever. So that's the whole general idea of what a bare metal switch is. It's just a piece of hardware that's built around a chipset from Broadcom or whoever it might be that does your switching for you in a very efficient manner. And so it kind of commoditizes the hardware, and you're putting whatever version of software you want and then manage yourself on top of these devices. Now, there's this category which includes bare metal switches and whitebox switches. The things that they have in common are that both of them are an attempt to get away from, the vendor hegemony state that we live in, where, you buy something from Cisco, you got to buy everything else from Cisco. You're tied into their proprietary protocols. And I'm picking on Cisco, but of course the same is true of HP or Alcatel-Lucent or any of the other vendors that you could get stuff from. So not being tied to a particular vendor, but running stuff on commoditized hardware is what both bare metal switching and Whitebox switching are addressing. Now, distinguishing the two can be a little bit difficult because, it's just words and people can use the words to define whatever. I just had this in a discussion with one of my colleagues yesterday for some of the software that we're building, finding something in a database and making a distinction between filtering stuff versus searching for stuff. And, the definition can depend on who you are and what time of the day you're talking about it. But the best description that I have read about the distinction between the two, and really what you should do is not marry the words to the definition, but just understand that there are different definitions. People tend to talk about white box switching in the SDN world as being a generic commoditized appliance that runs OpenFlow switching software on it. And people like Big Switch and Broadcom and Acton and others have gotten together and created this group that I think is called Switch Lite, that is a distribution of software and hardware that falls into this white box switching category. Other vendors create their own switches that are OpenFlow based switches that you could call white box style switches, in that they're less expensive. They're generic in the sense that they support OpenFlow, and therefore it should run in any OpenFlow environment. That's kind of what people have used historically to mean white box switches. Bare metal switches, on the other hand, are more aligned with what I described earlier, which is you have a piece of hardware that has, Marvell or Broadcom or whoever's chips on it, hardware built around it in terms of ports and power supply in the case that it sits in, etc. And that comes without any software. And you then load your Open Networking Linux or Cumulus or whatever it might be on top of that device. And then you have this generic network-oriented Linux operating system running on that device. And that's kind of the bare metal idea.
So, Chuck, you mentioned Cumulus. So Cumulus, as a company, sell Cumulus Linux. So that's kind of an example of what you would call bare metal switching. Is that right?
Yeah, I think it's a little bit a step above bare metal, because what they've done is they're actually packaging an operating system that was originally open source, but now it comes as a Cumulus piece of software. I don't know the details of what you can and can't load that software onto in terms of what Cumulus requires, but since they've built a large-ish anyway, infrastructure for support around this model, then there are going to be certain pieces of hardware that they will support and other ones that they won't support. But they would tell you that they've hardened the operating system, and they have 24/7 support that you can purchase so that you're not out on the limb. The risk of pure bare metal switching, of course, is that it's just you. You bought the hardware, you bought the software, and now you got to do something with it. And if it fails, you got to figure it out. With something like Cumulus, you're getting the value of a bare metal type of price and environment, but you don't have the same risk. You don't undertake quite as much risk on yourself to fix problems if you find them. You can call somebody and get their help in terms of support.
Yeah, so in its purest form, if we think about bare metal / white box switching, because I also hear these terms interchangeably, it's similar to buying a PC where you just buy the cards and the pieces and you put it together yourself, and then you load Linux on it yourself, like Ubuntu, but there's no support. You're on your own kind of thing. That's the purest form of this. Is that right?
That is correct. Yep. Yeah, and I mean, it's a little bit like Red Hat, right? So you can get Linux and be in charge of the Ubuntu or whatever, and be in charge of maintaining it and making sure that it's up to date. And you can go to all the Ubuntu boards and you can ask questions, etc. But you're a little bit on your own. Whereas if you purchase Red Hat, then not only do you get that version of Linux, which is hopefully hardened, hopefully has more diagnostic capabilities in it, but in addition to that, they have support lines that you can call that will help you out.
So Chuck, so basically it's kind of like open networking Linux on a switch. You're on your own, but with Cumulus, it's kind of like Red Hat kind of setup. Is that right?
That is the correct idea. Yeah. So open networking Linux is basically the software that's available to you. I think it was part of the Open Compute project that it was placed there. The Linux Foundation is kind of snarfing all kinds of things up in terms of SDN controllers and OVS and things like that. So I don't know if they've gotten involved in that at this point, but yeah, that is the general idea. It is software that you get, I guess there, and if you get Cumulus, then you get support and hopefully hardened, more stable version of the software. I guess in the data center world, getting a pure OpenStack versus getting OpenStack from any of the vendors that release distributions and support it, that would be another analogy.
So Chuck, you've mentioned two terms. I just want to tell people what those are. You mentioned OCP and you mentioned OpenStack. Can you give us a brief overview of what that is and how they related or if related?
Yeah, sure. So the Open Compute project started by Facebook. The general idea is, hey, here's some people who have learned things about best practices for installing and maintaining in a data center environment, including server storage, networking, etc. And so that's what the Open Compute project is all about, people sharing ideas. And, just to sort of compare and contrast, not that I have favoritism towards one or the other, but Facebook seems to be pretty good about openness and making things open source. Amazon, who, I'm an Amazon Prime person, I love it. I've good friends who work in high places at Amazon. They don't tend to reveal all that they've done. So my friend who implements Amazon's SDN-ish strategy for Amazon data centers and all their hundreds of thousands of networking devices, he can tell me bits and pieces about what he's done, but they don't make that open and available to everybody. Where on the other hand, the idea of the Open Compute project and its descendant, its creations, things like Open Networking Linux, is to make that information publicly available, whether that information is in the form of best practices or whether it's in the form of actual software.
And the other thing was OpenStack. What is that related to any of this, or is that something totally different?
Yeah, I mean, basically, us computer guys got together about 10 years ago and said, how can we really, really screw up everybody who's trying to learn about stuff? And somebody said, hey, why don't we just put the word open in front of everything? So we have Open Networking Linux, we have OpenStack, we have Open Flow, we have OpenView, a product that I used to work on, Open this, Open that, etc. We have Open Switch, we have Open Virtual Switch, all these things. So yeah, what is OpenStack? OpenStack, that's a joke, by the way. We didn't really get together and do that, although it would have been a good idea. So OpenStack, the general idea of OpenStack is people getting together and saying, you know what, we're all trying to solve this data center problem that involves servers, storage, networking, and the software that runs on top of them. What if we get together and we design this in such a way that the applications that we build on top of all of these pieces of hardware can utilize them in such a manner that it's consistent across all the vendors that may be providing those components. So it doesn't matter if the servers are from HP or Dell or Cisco or whoever, as long as there is OpenStack running on them, then an application is able to use them independent of the vendor that particular piece of hardware came from. The same is true of storage, and the same is true of networking. And what they did was they basically describe your data center network as pools of resources. So if I'm writing an application, then I need some compute power. So I go to the pool of compute resources and say, hey, I need a compute resource that meets these characteristics. And OpenStack service is able to provide me with that capability. I say, hey, I need some storage that meets these requirements, is this large, or I need some networking that meets these requirements. I'm basically asking the resource pool to provide me these items, which I can then use in my application. And the way that they did it, number one is it's the responsibility of the vendor to integrate their piece of hardware into the OpenStack environment. So I, as a networking vendor, need to create software that will satisfy these requests for networking resources. I, as a compute vendor, need to create software that will allow my compute resources to be placed in a pool and requested in the manner that I described. And the same is true for storage. So they made it so that it's the responsibility of the vendor to create the software to satisfy these requests. And the second thing that they did is useful is they created these requests for resources are all in the form of RESTful APIs. And so I, as an application developer, make REST API calls into this abstract interface. In other words, an interface that's designed to work for every type of vendor down below. It's actually designed to work in an abstract sense, and the vendors have to implement it. Since it's defined in this abstract manner, then I, as an application developer, am insulated from changes of the vendors from one vendor to another, or even within a vendor in how they satisfy those requests. So that's the general overview of OpenStack. OpenStack started out only defining servers and storage because they figured what's networking, it's no big deal. It'll just be part of your compute request is that you need networking. But then they realized that networking was a big enough thing that hey, we better define our own project in OpenStack that's related to networking, and that's called Neutron. It went through a few name changes and collisions with other things that were named the same thing, getting sued, etc. But I think it's Neutron now. And I guess one of your follow-up questions, David, might be, how does OpenStack relate to OpenFlow, or maybe even better, how does OpenStack relate to SDN? And the answer to that question is that OpenStack does not require software-defined networking, but to the extent that software-defined networking is able to satisfy these resource requests at massive scale, because that is the goal of OpenStack, is to deal with things at this really massive scale. To the extent that SDN is able to do that, then OpenStack can make use of it. But like I said, the vendors create the implementation of satisfying resource pool requests. That request can go to a particular device. So you can imagine somebody saying, hey, I need a network that has these characteristics for this tenant, and Cisco or whoever writes the code that allows that resource request to be satisfied for their physical devices. You can also imagine in a network that is software-defined networking, like an overlay network that we've mentioned, like an OpenFlow-based data center network like NEC or Big Switch provide. It can be satisfied in those manners as well. So this level of abstraction is really useful. The application doesn't have to know whether it's SDN being used to satisfy the request or whether it's a physical piece of hardware or a virtual switch. Any of those things can be used as a means to satisfy the request.
So if I understand right, Chuck, you as a developer could make a REST API call saying I need a server of some description, and that would be provisioned. Then I need some storage, and that would be provisioned. And then I need, let's say multiple servers with multiple storage, and then I need to connect them in a specific VLAN. And that just happens magically below through OpenStack. Is that right?
Yeah, probably the operative word is magically and works, but because I know some people have had some problems getting OpenStack to work, but that is the general idea. And I would say, I can't remember if we mentioned this distinction of declarative versus imperative. In a declarative system, you specify what you want, and the system figures out how to do it. In an imperative system, of course, you specify how to do something, and you hope at the end of the day it does what you want. If this was an imperative API, then we would say, hey, I want a VLAN, because we know networks have VLANs, and we know that that's 802.1q and that there's 12 bits, and I can only have 4,094 of these because 2 are reserved, et cetera, et cetera. If we were working in a more declarative world, which is what OpenStack tries to get towards, you would say, and I need a network for these resources to live on. And so however that network request gets satisfied, it could be a VLAN if it's a hardware implementation. It could be a tunneled network, virtual network identifier if it's in an overlay type solution. It could be some other mechanism, but NEC, it would be a virtual tenant network. Big Switch, it would be whatever they call it. So, yeah.
Yes, so you wouldn't. Yeah, it's incorrect to say specify the VLAN. The idea is just have this network, and it magically happens.
You're truly a networking guy, David. Yes, you can't help talking in those terms.
Exactly.